Welcome back. Let us see what are the different methodologies are applied to reduce the power consumption. In previous sessions, we have seen that what are the different sources for the power consumption in the VLSI circuits. By studying those power sources, the power consumption on which factors it depends that we observed. That is, the power consumption includes two types of powers. One is the static power consumption and the another one is dynamic power consumption. Out of these two, the most effective power consumption is dynamic power consumption, right? So with reference to dynamic power consumption, if you see the formula of the dynamic power, that is VDT square CL into F. That means the dynamic power is directly proportional to square of the applied voltage, load capacitance, and switching frequency. So by working on these three parameters, you can reduce the power consumption, right? So the techniques which you can apply to reduce the power consumption is either you can work on applied voltage, okay, that is applied voltage means supply voltage, or you can work on capacitance, and also you can work on switching activity. Okay, by observing that formula, the power consumption, that is dynamic power consumption, directly proportional to these three. Okay, if any one of these reduced, automatically the dynamic power consumption also reduced. Totally the power consumption in the MOS circuits or VLSI circuits can be reduced. In addition, you can also work out on reducing the threshold voltage. Okay, by working on the threshold voltage also you can reduce the power consumption value. Okay, so therefore now what are the different methodologies to reduce the power consumption is voltage scaling techniques. Okay, voltage scaling techniques, um, switching capacitance, minimizing the switching capacitance technique, and reducing the switching activity techniques, and one more is minimizing leakage power techniques. Okay, so the different methodologies or approaches to reduce the power consumption are supply voltage scaling. Supply voltage scaling means reducing the applied voltage. Okay, so minimizing switching capacitance. Switching capacitance or effective capacitance, also you can call load capacitance, because the dynamic power is directly proportional to the load capacitance. And switching activities, if you reduce the switching activities, means the transitions, reducing the number of transitions, you can reduce the power. That is the another approach. And one more approach is decreasing leakage currents, decreasing the leakage currents, so that the leakage power can be reduced. But all these techniques you can apply at different levels of uh, at different levels in the design process. In the VLSI design process, you have various levels from the that is from the system level to the device level. Okay, so the various levels are like system level, architectural level, behavioral level, device level. Okay, so in any level almost you can apply these techniques to reduce the power consumption. Okay, so but if you see, if you apply the voltage scaling techniques, what happens is the power consumption will be reduced, but at the same time what happens is the performance of the circuit also reduces. Here performance is generally the synonym for the speed. Okay, so speed is reduced, but our intention is the speed must be high. Okay, so when you apply the voltage scaling techniques, the power consumption no doubt can be reduced, but at the same time the speed also reduced. But the aim is the system has to be work at high speed. So along with the reduction of power, we also think that to improve the speed. Okay, so for that, different techniques are there again, or different approaches you can apply from the system level to device level, like uh, transistor size scaling, architectural level approaches, parallelism, okay, pipelining, like that. Some techniques you can apply to improve the speed. Okay, so whereas in the approach like reducing the switching capacitance, in the switching capacitance case, generally the technique is implementing hardware software co-design techniques. Okay, implementing hardware software co-design, that means out of all the functions of the system, certain functions can be done by the software and certain functions can be done by the software. So if you divide the total functions of the system, like the functions done by the software and the functions done by the hardware, also you can reduce the power consumption. This type of technique reduces the switching capacitance. Okay, then coming to reducing the switching activity approach, reducing the switching activity or number of transitions. Okay, so here in the in this case you can apply the techniques like implementing different types of complementing techniques, like you have the two's complement method. Okay, instead of two's complement method, if you use sign magnitude techniques, the number of transitions can be reduced. Okay, similarly, different coding techniques, by applying different coding technique like um, hot coding, gray coding, like that. If you use those, the switching activities can be reduced. Okay, and finally, you can work out the reducing the leakaging currents. Okay, so like that, different methodologies or approaches you can apply from the system level to device level in the design process of VLSI system, so that the power can be reduced. Okay, so the detailed analysis or actions of these things you can see in the further classes.